There are countless galaxies of all shapes and sizes in the universe. In this video, we'll take a look at 10 of the most unique and mind-blowing galaxies in the cosmos. Segue 2. This is currently the smallest and faintest galaxy humans have discovered. Found in 2009, it's a satellite of the Milky Way, about 110,000 light-years from Earth. Its diameter is only about 68 light-years, and it contains fewer than 1,000 stars. What's more, the stars it does contain are all old ones that formed 12 billion years ago. And no new star formation has been detected so far. That means the stars inside it may well be among the very first generation to form in the universe. You might wonder, with fewer than 1,000 stars, isn't the stellar density too low? Why is it classified as a galaxy rather than a star cluster? The main reason is its large mass, about 600,000 times the mass of the Sun. If fewer than 1,000 stars can amount to that much mass, what else is in there? Dark matter. Current research shows this galaxy contains a great deal of dark matter. Although we can't see dark matter directly, we can infer its presence from its gravitational effects. Just as we can't see the wind itself, but we know it's there from the way it moves the leaves. Large and small Magellanic Clouds. We'll talk about these two together because they're the Milky Way's most famous satellite galaxies. The Small Magellanic Cloud is about 200,000 light-years from Earth and roughly 7,000 light-years across. The Large Magellanic Cloud lies about 160,000 light-years away and spans about 14,000 light-years. Despite being called clouds, they aren't true nebula, but dwarf galaxies. Their names come from the 16th century Portuguese explorer Ferdinand Magellan. He was the first to lead a fleet around the globe and the first European to observe these two clouds from the southern hemisphere. At the time, astronomers didn't distinguish between nebula and galaxies. Anything faint and fuzzy that wasn't a single star was labeled a nebula. It wasn't until the early 20th century that the categories were clarified. If a system is mainly gas and dust clouds, it's a nebula. For example, the Orion Nebula, the Horsehead Nebula. If it's an independent system made up of vast numbers of stars, gas, dust, and dark matter, like the Milky Way or Andromeda, then it's a galaxy. By that definition, the Large and Small Magellanic Clouds clearly belong in the galaxy camp, but historical usage kept the cloud names. Of the two, the Small Magellanic Cloud is the more mysterious. According to the latest research published last year, it isn't a single galaxy at all, but two aligned along our line of sight, one in front and one behind. So what we've been seeing is the foreground galaxy with the background one largely hidden. How did the Small Magellanic Cloud form? One hypothesis is that the Milky Way's gravity tore it from another system, which helps explain its irregular shape. Studies also show the Small Magellanic Cloud is still being tugged by the Milky Way and the Large Magellanic Cloud. Gas and stars are steadily being stripped away. It's expected to dissipate in a few 100 million years, while the Large Magellanic Cloud is likely to merge with the Milky Way in the future and become part of it. Triangulum Galaxy, M33. Its diameter is about 60,000 light-years, and it lies 2.73 million light-years from Earth, making it the third largest galaxy in the local group, after Andromeda and the Milky Way. M33 is also a spiral galaxy, but not a barred spiral. It lacks the central bar. Its spiral arms aren't as tightly wound as in typical spirals, giving it a loose, open appearance. At first glance, M33 looks somewhat reddish overall. In fact, Those are red emission nebulae. The most famous is NGC 604, an enormous, very young nebula more than 1,500 light-years across, where millions of young stars are being born. It's currently regarded as the most active star-forming region in the local group. Current observations further suggest that M33 may be one of Andromeda's satellite galaxies, as it appears to be orbiting Andromeda at about 190 kilometers per second. This speed shows M33 is under Andromeda's gravitational influence. However, that alone doesn't prove it's a bound satellite. We still need to determine whether its orbit is stable, i.e. whether it might be moving fast enough to escape Andromeda's gravitational pull. Whirlpool Galaxy M51. It's about 86,000 light-years in diameter and lies some 31 million light-years from Earth. The galaxy was first noted by the British astronomer William Parsons. Mistaken at the time for a whirlpool-shaped nebula, it was for a period the first known nebula with a spiral structure, and was later confirmed by Hubble to be a galaxy. You can see its two striking spiral arms, and the tip of one arm connects to a small, pale yellow companion galaxy. That's right, this is another galaxy pair, much like the small Magellanic Cloud case we mentioned earlier. When we say M51, we usually mean the pair as a whole. If we insist on distinguishing them, the main spiral is M51A, and the small yellow one is M51B. These two galaxies didn't form by splitting from a single large system. The yellow companion merely passed behind M51A. It wasn't originally in this position. What we're seeing now is the state after it traveled for hundreds of millions of years, and gravity is currently pulling the two around each other. In another 100 million years or so, it will have moved completely past M51A and will then be an independent galaxy. This galaxy can't be seen with the naked eye. If you have a telescope, first find the Big Dipper. Follow the handle to the last star, Al-Qaid. Once you've found it, stop and nudge the telescope a little to the southwest, and you'll spot the beautiful galaxy pair, M51. Milky Way. The Milky Way, our home galaxy, has a diameter of about 100,000 light-years and is the second largest member of the local group after Andromeda. Structurally, like Andromeda, it is a barred spiral galaxy, meaning there's a bar-shaped stellar structure at its center. The Milky Way has four primary spiral arms. The two that connect to the central bar are the Scutum Centaurus arm and the Perseus arm. Between them lie two smaller arms called the Norma arm and the Carina Sagittarius arm. So where are we in the Milky Way? We're actually quite far from the center. Our solar system sits nearly 27,000 light-years from the galactic center in a minor arm between those two main arms, the Orion arm. This small arm is about 3,500 light-years wide and more than 20,000 light-years long, and we're inside it. Nearby are familiar sights like the Orion Nebula and the Horsehead Nebula. This is a good neighborhood to be in. Get too close to the center and the entire solar system would be in peril. That's because the Milky Way's core hosts a supermassive black hole, Sagittarius A star, with a mass about 4.3 million times that of the Sun. The image of Sagittarius A star captured in 2022 was hard-won. Its apparent ring is roughly 60 million kilometers across. I doubt anyone would want to live near that. Much safer to remain in the Orion arm. You might also wonder how many stars and planets the Milky Way contains, and whether there's another solar system like ours. Precise counts are hard, but scientists estimate there are roughly 100 to 400 billion stars, and at least 100 billion planets in our galaxy, with more than 10 billion of those likely being rocky worlds. As for another solar system exactly like ours, one star with 8 planets, 4 rocky and 4 giant, none has been found so far. For now, ours is unique. That said, many similar systems do exist. For instance, a system discovered in 2017 lies 39 light-years away. It has 1 host star and 7 planets, 1 fewer than the solar system. The star is TRAPPIST-1, a red dwarf with a surface temperature about half the Sun's, a mass about 8% of the Sun's, and a radius about 11% of the Sun's. Overall comparable in size to Jupiter. All 7 of its planets are rocky. There are no gas giants. 5 are roughly Earth-sized, and at least 3 orbit within the habitable zone, though it's still unclear whether any have liquid water. If those in the habitable zone do host liquid water, they could be promising for life. Another example is Kepler-90, which is fairly famous. The star itself closely resembles the Sun, about 1.13 solar masses, 1.2 solar radii, and a surface temperature of 5,656 degrees Celsius, essentially a scaled-up Sun. Crucially, it also has 8 orbiting planets, matching the solar system in number. The 3 innermost, Kepler-90b, 90c, and 90I, are terrestrial super-Earths with radii about 1.31, 1.19, and 1.32 times Earth's. The middle trio, Kepler-90d, 90e, and 90f, are mini-Neptunes. Mini-Neptunes are a planetary class between rocky worlds and ice giants. Smaller than ice giants, typically 1.7 to 3 Earth radii, these 3 are 2.9, 2.7, and 2.9 Earth radii, and much hotter with thick atmospheres because they orbit closer to their star. In other words, a mini-Neptune is a gas-rich planet smaller than an ice giant. The 2 largest outer planets, Kepler-90g and 90H, are gas giants, with radii about 8 and 11 times Earth's, akin to Jupiter and Saturn. Taken as a whole, the system looks impressive, but there's a catch. None of its planets lies in the habitable zone. The orbits are very compact, so tight that even the outermost Kepler-90H circles closer in than Earth does. Hence, Kepler-90 is often dubbed a miniature solar system. Hughes object. The galaxies we discussed earlier are either irregularly shaped or spiral. The one we're looking at now is an exceptionally rare ring galaxy called Hughes object. This image was taken by the Hubble Space Telescope in July 2001. Its outer region is an almost perfectly circular ring of stars, while the center is a very bright, elliptical-like galactic core composed of old stars. Between the ring and the core is a conspicuous gap containing almost no material. The galaxy is about 150,000 light-years in diameter and lies roughly 600 million light-years away, very distant indeed. Interestingly, you can also see a small ring-shaped galaxy in the frame, but don't be misled. It isn't part of Hughes object. It's simply a line-of-sight coincidence. The smaller ring galaxy is actually farther from Earth. It just happens to sit in the gap as a background object, making it appear as though it were a component of Hughes object. Pinwheel Galaxy M101. M101 is a face-on spiral galaxy about 21 million light-years from Earth, with a diameter of roughly 170,000 light-years, nearly twice that of the Milky Way, and it contains about 1 trillion stars. This image was taken by the Hubble Space Telescope in 2006. As you can see, it isn't a perfectly symmetrical galaxy. The spiral arm on this side is broader and larger, with more stars and nebulae. Large nebulae such as NGC 5461, NGC 5462, and NGC 5458 all lie in that arm. The NGC numbers are similar to Messier numbers in that both label deep sky objects like nebulae, star clusters, and galaxies. However, the NGC, the New General Catalogue of Nebulae and Clusters of Stars, compiled by the British astronomer John Dreyer in 1888, includes many more objects than the Messier list. The first edition of the NGC recorded 7,840 objects, and over the years many more were added, so the modern NGC now contains over 13,000 objects. For example, the Andromeda Galaxy is M31 and also NGC 224, while the Pinwheel Galaxy we're discussing is M101 and NGC 5457. In short, apart from the Milky Way, from the late 19th to early 20th century, nearly every deep sky object that could be seen with a telescope and showed distinct features received an NGC designation. Why exclude the Milky Way? Because NGC entries are objects with clearly defined boundaries as seen from Earth. Since we are inside the Milky Way, we can't observe it as a complete, bounded object the way we do other galaxies, so it doesn't meet the NGC criteria. Tadpole Galaxy. As the name suggests, this galaxy looks like a tadpole. This image, taken by the Hubble Space Telescope in 2002, shows a system about 400 million light-years from Earth. The main galaxy is roughly 100,000 light-years across, and its tail is about 280,000 light-years long, giving a total length of around 380,000 light-years. The frame also contains more than 6,000 background galaxies besides the tadpole itself. How did the stellar stream in the tail form? The prevailing idea is that a very dense galaxy collided with and passed through the tadpole galaxy, dragging out some of its stars, gas, and dust to create the tail. Much like a tadpole on Earth, that tail is expected to fade over time and eventually break up into several small galaxies. NGC 68872. This is a gigantic barred spiral galaxy. Its two spiral arms look like an eagle's wings, which is why it's also called the Condor Galaxy. It lies about 200 million light-years from Earth, and its total length exceeds 520,000 light-years, 5 times the width of the Milky Way, making it the largest barred spiral galaxy currently known. Above it is a small companion galaxy, IC 4970, with a diameter of about 20,000 light-years. It's thought that the Condor's unusually long arms were stretched out by the gravitational pull of this satellite, producing those enormous wings. IC 1101. This is the largest elliptical galaxy known to humans, and, so far, the most distant galaxy discovered. It lies about 1.15 billion light-years from Earth and spans some 6 million light-years in diameter. Most of its stars are older than the Sun, giving the entire galaxy a golden hue. All right, that's all for the galaxies we wanted to show you in this episode. The ones we discussed toward the end are so distant that, for now, we don't have much definitive information about them. There are almost certainly galaxies out there, far larger than IC 1101. We just haven't found them yet, or they're simply beyond the reach of current human technology. But that's okay. Let your imagination run wild. What might the next discovered galaxy look like? Could it completely upend our understanding of the universe? Perhaps we'll have answers before long.